Hello everyone, welcome to Geeky Nerd. Today we will begin with the fourth video of the aptitude topic problems on trains. Before moving into the video, I hope everyone would have practiced thoroughly the previous three videos of this aptitude topic. If you have not seen those videos, please click on the card or the links in the bio. In this video, we will be discussing how to determine the speed when the faster train crosses the slower train, and also we will be discussing how to determine the distance, time taken and speed when one train travels extra distance compared to the second train. Like, share and subscribe the channel for more interesting concepts and shortcut methods for solving the problems. So without wasting any time, let's move into the video. Distance between stations. The two trains are starting simultaneously opposite to each other from stations A and B with speed of S1 and S2 respectively. They meet with each other at a point, and it has been found that one of the train has traveled longer distance to meet the other train. In such cases, the distance between the two stations can be given as distance is equal to small d, that is, the extra distance traveled by one train, the whole multiplied by S1 plus S2 divided by S2 minus S1. This method also has a traditional way of solving which will help us in understanding the concept easily. Let us move on to the next slide. It's actually common sense that when two trains meet or coincide with each other, the clock at that moment will be same for both the trains. That is, if train A meets with train B, then the universal clock will only denote one particular time. Taking that into consideration, we are going to equate time on both the sides, and thus we can calculate the distance between two stations. We know that the basic formula of time as distance traveled divided by speed. Therefore, let x be the length of train 1 and x plus d, that is length of the train 2 plus extra distance traveled as the distance traveled by the train 2. Equate the equation and get the distance between the two stations. Let us solve some examples to understand this subconcept. From stations M and N, two trains start moving towards each other at speed of 125 km per hour and 75 km per hour respectively. When two trains meet each other, it is found that one train covers 50 km more than the other. Find the distance between M and N. So here we assume that S1 is equal to 75 km per hour, S2 is equal to 125 km per hour. The distance extra traveled is equal to 50 kilometers. We need to find the distance between the two stations M and N. So we know that when two trains meet each other, then time taken will be equal for both the trains. Under this condition, now we will be equating T1 and T2 and find the distance between the two stations. We know that time is equal to distance traveled divided by speed. Therefore, T1 is equal to D1 by S1, which in turn implies as T1 is equal to D1 divided by 75. So this is first equation. Similarly, T2 is equal to D2 by S2, which implies T2 equal to D1 plus 50 by S2 will be 125 kilometers per hour. So this will be equation 2. Upon equating both, we get D1 by 75 is equal to D1 plus 50 by 125. Therefore, 125 d1 is equal to 75 d1 plus 3750. 50 d1 is equal to 3750. Upon cancelling, we get d1 is equal to 75 kilometers. So substituting it in D2, we get D2 is equal to 75 plus 50, which is equal to 125 kilometers. But the question refers to the distance between the two stations. Therefore, distance between two stations is equal to d1 plus d2, which is equal to 200 kilometers. Thus, by identifying the individual distances of the train d1 and d2, we can compute the distance between the two stations successfully. Let us solve one more example to understand this concept. From stations A and B, two trains start moving towards each other with the speeds of 150 km per hour and 130 km per hour respectively. When the two trains meet with each other, it is found that one train has traveled 20 kilometers more than the other train. So find the distance between the stations. So here S1 is equal to 150 km per hour, S2 is equal to 130 km per hour, and T equal to 20 minutes. As we discussed in the previous problem, when two trains meet, time taken will be equal. We know the basic formula of time taken as time taken is equal to distance by speed, which implies T1 equal to D1 by S1, which is equal to T1 equal to D1 by 130. This is first equation. Similarly, T2 equal to D2 by S2, which is equal to D1 plus 20 divided by 150. This is equation 2. Upon equating 1 and 2, we get d1 by 130 is equal to d1 plus 20 by 150. Upon solving, 150 d1 is equal to 130 d1 plus 2600, which in turn will give 20 d1 equal to 2600. Therefore, d1 equal to 130 kilometers. So once found d1, we can write d2 equal to d1 plus 20, which is equal to 150 kilometers. Therefore, distance between two stations can be written as d1 plus d2, which is equal to 280 kilometers. Thus, in this problem also, we successfully computed the distance of train 1, distance of train 2, and then by adding both the distances, we found out the distance between the two stations. In this concept, we will determine the speed of the individual trains based on the length and the time taken. So it is given that two trains of length L1 and L2 run on parallel tracks. When they run on same direction, they cross each other in t1 seconds, and when they run on opposite direction, they cross each other in t2 seconds. It is very clear that faster train only will cross the slower train. Therefore, in both the cases, we need to find speed of the faster train and speed of the slower train. So, it has been given by the formula speed of the faster train is equal to L1 plus L2 by 2, the whole multiplied by 1 by T1 plus 1 by T2. Speed of the slower train is equal to L1 plus L2 by 2, the whole multiplied by 1 by T1 difference of 1 by T2. Here, whichever time is found to be lesser from the question, that should be accepted as T1, and whichever time is greater in the question, that should be regarded as T2. Let us solve some examples to understand how this complex concept works out. Two trains of length 200 meter and 175 meter are running parallel. When they run in same direction, the faster train crosses the slower train in 37.5 seconds, and when they run in opposite direction, faster train crosses slower train in 7.5 seconds. Find the speeds of each train. So from the question, we can clearly understand that length of train 1 is equal to 200 meter, length of train 2 is equal to 175 meter. When the faster train crosses the slower train in same direction, T1 is equal to 37.5 seconds, and when the faster train crosses the slower train in opposite direction, T2 is equal to 7.5 seconds. Find the speeds of each train. So from the concept, we clearly know that speed of faster train is equal to L1 plus L2 by 2 whole multiplied by 1 by T1 plus 1 by T2, which in turn can be written as 200 plus 175 by 2 into 1 by 37.5 plus 1 by 7.5, which is equal to 375 by 2 multiplied by 6 by 37.5, which in turn will give 30 meter per second. Therefore, speed of the faster train is equal to 30 meter per second. Similarly, speed of slower train is equal to L1 plus L2 by 2, the whole multiplied by, we can consider either 1 by T2 minus 1 by T1 or 1 by T1 minus 1 by T2 as per our wish. Therefore, 1 by T2 minus 1 by T1, which in turn implies 200 plus 175 by 2, the whole multiplied by 1 by 7.5 minus 1 by 37.5. Upon solving, we get 375 by 2, the whole multiplied by 4 by 37.5, which in turn will give 20 meter per second. We have successfully computed the speed of the faster train and the speed of the slower train, referring the formulae we studied in the concept. Through this video, we had determined how to calculate the speed, time taken and distance when the faster train travels extra distance compared to the slower train. We also saw how to determine the speed of either the faster train or the slower train when the faster train crosses the slower train. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share and subscribe the channel. Also convey it to your friends so that they can be benefited. Until we meet in the next video, thank you.